Okay, in this video lesson, we'll do a review of trigonometry, and we'll look at the foundations where trig actually originated from. So, back in grade school, we were first presented with a triangle. And with a triangle, each triangle was a triangle because of it had three different sides. So each side was just basically called a side. Then we look at specific types of triangles, specifically the right triangle. And with the right triangle, we evolved from just naming the sides generic sides until we had two legs, and the third side was the hypotenuse. So the two sides that made up the right angle, we named them legs, and the side that was across from or opposite the right angle was named the hypotenuse. Then we take it one step further. We look closer at the angles. We had the right angle and two specifically acute angles. And so based upon this, we began to name each side with its own independent name. The legs were now had specific names, depending upon which acute angle you are referencing. So if I was at this particular acute angle, then the legs had very specific names. The leg right next to that acute angle was called adjacent, and the leg across from that acute angle was named opposite, and the hypotenuse kept its name as hypotenuse. But if we had the same triangle, the right angle and the two acute angles, but now if we were referencing this acute angles, the legs took on different names. This leg that is now next to the acute angle was called adjacent, and the one across from it was opposite. So this first distinguished that the opposite and adjacent, the names of those sides depended upon which acute angle you were referencing. And of course, the hypotenuse stayed where it was. So we went from side, side, side to leg, leg, hypotenuse to specific names opposite, adjacent, and hypotenuse. So we'll look at these three words, opposite, adjacent, and hypotenuse. And where the foundation of trig comes from is we take these three sides and begin to create ratios of two of the three sides. So if I took any two of these three, let's say the opposite compared to the hypotenuse, and I'm writing it as a ratio form or as a fraction, I can take two different sides, perhaps adjacent compared to hypotenuse, and another is opposite to adjacent. Now, because I'm writing them in ratio form, and they do represent lengths of sides of right triangle, opposite to hypotenuse could have been the opposite side maybe 3 units long, while the hypotenuse was 5 units long. So theoretically, I could reverse this and have a totally different ratio. So instead of opposite to hypotenuse, hypotenuse to opposite. Totally different ratio. Same with the other two. Adjacent hypotenuse, hypotenuse to adjacent. Opposite to adjacent, adjacent to opposite. So when we take these three different sides, specifically opposite, adjacent, hypotenuse, and take any two of them and create a ratio, there's a total of 6 different ratios that we can form. And so once we have these 6 ratios, we then begin to give each ratio its own name, an identifier. So with opposite to hypotenuse, the name given was sine. Adjacent to hypotenuse, cosine. Opposite to adjacent, tangent. So these red words that I have, they are essentially, for all practical purposes, a nickname for each of the different ratios. So the other three ratios, they have their own names. So hypotenuse to opposite, cosecant, hypotenuse to adjacent, secant, and adjacent to opposite, cotangent. So these make up the 6 trigonometric functions, which are the red words. The red words are the trig functions. The corresponding ratios are the words in purple, green, and yellow. Now, with each of the 6 red words, the 6 trig functions, there's actually an abbreviation for each of the 6 words. the abbreviation is a three-letter word. So for sine, the abbreviation for sine is SIN. Before I go forward, it's still pronounced sine. Yes, it looks like it spells sin, but because this is just the abbreviation for this word, it's still pronounced the same way you would say the entire word. So it still says sine, cosine would be COS, still pronounced cosine, and tangent TAN. With the other three, again, it's a three-letter word. Now, cosecant, with the first three, we were just taking the first three letters of each word. Can't quite do it here because COS has already been reserved for cosine. Cosecant takes the first letter of each syllable. Co, C, and cant. CSC, cosecant. Secant, SEC, and cotangent, COT. So what we now have are our six, again, trigonometric functions, which is the red or blue abbreviations, and the corresponding ratios. When you are first presented with this entire schematic here, that may be a little bit overwhelming. So there's a mnemonic device to help you keep track of this. The mnemonic device is Sokatoa, similar to PEMDAS for our order of operation, PEMDAS, where each letter stands for one of the different operations. Sokatoa is similar in the sense. So the so part, SOH, S standing for sine, O and H opposite the hypotenuse. Ka, CAH. C is the cosine, A adjacent, H hypotenuse, and TOA, TOA, tangent, opposite over adjacent. So, ka, TOA. Personally, Sokatoa really didn't flow with me when I was first learning this, primarily because Sokatoa relies upon you being able to spell Sokatoa correctly. And Sokatoa typically would not be spelled SOH. At least I would not have thought to spell it SOH. I tend to segue to something that I'm familiar with. I'm familiar with a word that rhymes with Sokatoa. Sokatoa rhymes with a refreshing beverage that we're all familiar with. Sokatoa rhymes with Coca-Cola. Now here's what I'm doing. I'm trying to take something that's unfamiliar to me to something that is familiar. Coca-Cola rhymes with Sokatoa. And what's nice about using Coca-Cola, if someone was to offer you this refreshing beverage, you might first say, "Oh, thank you. Oh, thank you." And in an English class, O is spelled OH. Once you consume the beverage, soon as you finish that last little chug, we typically would say, "Ah." Ah, in an English class, it's spelled AH. So the Coca-Cola reference to Sokatoa could help take something that's unfamiliar, Sokatoa, related to something that is familiar, Coca-Cola. And with the Coca-Cola, again, the words O and ah relate back to the trigonometry. So Sokatoa, O, ah, O, ah, O, O-H, ah, A-H, O, ah, Sokatoa. So with this review lesson, it's just presenting the six trigonometric functions and its corresponding ratios. So the Sokatoa could help you with creating the first three. The last three, the most obvious thing is that each ratio is the reciprocal of the other side. So the only thing one has to keep track of is which trigonometric function do I assign to each of the different ratios. Well, out of all the six ratios, the only one that really kind of flows is tangent and cotangent. The words tangent and cotangent do sound like opposites. So opposite adjacent, adjacent opposite. These flow. So when I look at the other, I need to find something that distinguishes the word to sound like its opposite. And what I see is the prefix co. Tangent, cotangent. So the co is the opposite. So if I already have cosine here, I need a word that doesn't have the co. Again, back to tangent. No co for tangent. Its opposite has a co. A co for cosine, I need a word with no co associated with it. Secant is the only word left over. Inversely, sine has no co, so its opposite trig function has a word with the co. Just a little bit to kind of sort of help organize the different bits of data. So, o, I. Then we look for opposites. No co for tangent, co for tangent. Co for sine, no co for secant. Sine, no co. Co is its opposite, cosecant. So hopefully this review will be something you can refer back to as we move forward.